Welcome to the lecture series in computer science on principles of deep learning. In today's session, we are going to discuss on TensorFlow libraries. And moving on to the agenda of today's session, I am going to introduce you the various built-in libraries in TensorFlow, the simple codes which makes up to build the real world applications, and conclusion. And to start about TensorFlow, in previous session I have given you an introduction about what a TensorFlow is. To recap the memory, here again TensorFlow is developed by Google and it is written in Python language. It is designed to build and train machine learning and deep learning models, and here it is an open source framework which supports the CPU, GPU and TPUs for faster computation. And to just know about what the Keras libraries will focus on, it is also an open source neural network library. It runs on the top of Theno or TensorFlows, and this is a low level application programming interface. Now, to just know about what it is, a TensorFlow, we have the way of handling the data in form of a scalar, vector, matrices or the tensors. And here to know about the characteristics or components of a TensorFlow, the keywords or buzzwords associated with tensors are the shape, the rank, the data type. So, shapes are tensors which have or which will determine the dimension and size along each of the axes. Moving on to the data type, it defines actually or describes the type of data that is stored in the elements. And to move on to the rank of a tensor usually indicates the number of dimensions it holds. For example, if you have a scalar value, the rank of that particular tensor we call it as 0. If we have a one dimension array, we call the rank as 1, and in matrices where it is a two dimension array has a rank of 2. Now, moving on to the other buzzwords associated with the TensorFlow, there is an axis and value associated with each of the tensors. An axis will refer to a dimension in a tensor, and these represents multiple axes which represents the different dimensions of the data. And to just give an example, a 2D tensor will have 2 axes, a 3D tensor will have 3 axes. In case of 2 axes we call it as rows and columns, and in case of 3 axes we call it as height, width and depth. Now, moving on to the values in tensors, the values of the tensors can contain or they are the elements that are stored in contiguous memory blocks, and these values can be accessed, manipulated using the various TensorFlow operations. To know the exact difference between the TensorFlow and Keras library, here we have some of the major differences between these two libraries. Now, here in TensorFlow, it is purely written in C++, CUDA and Python language, whereas Keras is purely written in Python language. And here the TensorFlow can be used for large data sets and high performance models, whereas Keras is usually used for small data sets. And here the TensorFlow, the framework offers both high level and low level APIs, whereas the Keras always supports the high level APIs. Now, moving on to the actual how the performance architecture will be there. Here the tensors is a complex architecture, whereas the Keras is a very simple architecture. And we know Keras have been developed by Francis Collett while he is working on part of a research project called 1-IROS. Here TensorFlow is developed by the Google Brain team. Now, to know about what makes the Tensor libraries, what are the different functionalities that are available in these libraries, to summarize a few. Here we call TensorFlow is the core computational ML or DL library, and TF-Keras is the high level API for building the neural networks. TF.data is the input pipeline construction which helps to construct the tensors in batches or to perform shuffling or to map the elements. Now, moving on to the other core libraries that are available in TensorFlow, TF.summary is a function which helps for logging and visualization for tensor boards, and TF.function compiles the Python functions into TF graphs. And tf.math, we all know all the mathematical operations can be performed over tensors like addition, subtraction, etc. And tf.random, random number generation for tensors. And moving on to the other libraries that are available in TensorFlow, there is a library for model deployment and utilities, and a function that is helped to do this is tf.saved_model, which is used to store the models for deployment as well as load the models. And here there is tf.keras.models, which helps to load the model or train or clone the model management. Now, here keras.preprocessing library, it helps for image and text processing, pre-processing utilities. And moving on to the other pre-trained models and applications, we have tf.keras.applications, which are pre-trained CNN models, which will be useful for ResNet, VGG and MobileNet. And here the TensorFlow Hub is a reusable pre-trained models for natural language processing, okay, especially for vision. And TensorFlow.Lite, it is mainly used for mobile and IoT applications. And we have one more library called tf.js, which is mainly used for JavaScript and web applications. Now, here before moving on to the complex machine learning and deep learning models, which will be dealt shortly in our forthcoming sessions, here I just want to introduce you to how it will be actually how to use the TensorFlow, the basic structure, how it can be used in any of the particular real world applications. To start with, now here I have taken how to create a simple tensor. So, we have to import the library name is TensorFlow, and it has been given with a name, variable name called tf. So, in this way we have to import the TensorFlow, and here if you want to wish to have the version of TensorFlow what you are using, you can just have a printout called print, in double quotes you can see the TensorFlow version with a built-in function called tf._version_. Now, moving on to how to construct a simple constant tensor, I have given the name for the constant tensor as hello TensorFlow, and we have to use a built-in function called tf.constant to build this tensor, and it is given the handle to the hello variable. Now, if you print hello.numpy, we will just be created a simple tensor. Now, moving on, how a constant and variable can be created under the TensorFlow libraries, how we have to create that while we are doing or building a mega complex machine learning models. Now, here import TensorFlow as TF is the basic way of importing the library. Then see here we can call the TensorFlow the constant function with the single dimension array 10, 20, 30, and here the print statement gives the actual tensor that was created. Now, how to use a variable tensor? Here a variable tensor is also been created with one dimension array. We have taken tf.variable as the function name, and we have given the input parameters as 1.0, 2.0 and 3.0, and if you print the variable tensor that has been created will just be printed over. Now, just the next type of operations is how to do mathematical operations with these TensorFlows. If we know the basic concepts of how a tensor will be imported using the import statement, and how the different simple values or variables can be created using the TensorFlow libraries, this helps us to build the complex projects. Now, here we have taken a, b as two constant tensors with the basic values or the two dimension array 2, 4 and 1, 3, and here I am calling addition, multiplication and square functions that can be applied to any of the existing tensors. Now, if I say add is equal to tf dot add of a comma b, the two tensors have been added, and if I say multiply, two tensors have been multiplied, and this is the way how we can print the values that is there in the tensors. Now, to work on it, how the output appears, we need to just open the Google Colab, and we can even have this code onto the Google Colab. I think these bulleted points are here only for the way of expressing the code. We all know that in Python these bulleted are never been accepted, and it always follows some indenting process. So, this program if we apply in Google Colab, we get the necessary or the output addition of two sensors, multiplication of two sensors and the squaring of a particular sensor value. Now, moving on, how that string operations takes place in sensors. To just give a idea about how it can be utilized in case of string operations, here I have taken a variable scalar string tensor, a vector string tensor and a matrix string tensor. So, now I have to supply the values to the constant parameter, saying that here one single value has been given Tf dot constant, and in the subsequent examples I have given 3 words in a particular single dimension array, which says that it is a vector representation of the tensor, and in the matrix format I have called the matrices 2 by 2 matrix here. So, the values initial values have been supplied to the matrix, and hello is one word, world is another word, TensorFlow rocks. So, these helps us to how these string operations can be performed using the TensorFlow libraries. Now, to have a good example how concatenation or splitting happens in TensorFlow, we can take this example. Suppose take string 1, I am supplying the constant value of hello, and string 2 I am supplying the constant value of world. So, if I join these two and I can see the result, the output is hello world. The tensors has been concatenated, and these why we are learning all these simple operations to just better well known with the syntax when we are doing a complex program. Now, see the other example, it is splitting. So, here with the constant value I have given welcome to TensorFlow, and here I have used the string split function, which says that the sentence can be splitted or the sentence can be used to split with the character set UTF-8. So, if I print character 0, then it prints the first character that is stored in the particular string value. So, this will be the output. I have got a tensor and saying that the first word is being taken, that is welcome is the first letter that gets displayed over here. Okay. So, moving on to the next example, how the TensorFlow can be applied for comparison or pattern matching. So, if I see the first code here, hello world is being taken as string constants, and I have made or called a function called equal. So, I just compare string 1 with string 2, and the output, if it is same, we will get a value of true, as the input values that has been supplied is hello and world, which is both are contradicting words, we got the outputs as a false statement. Now, moving on to pattern matching. So, here I have taken two constants called 10 and 10 is the input parameter that has been supplied to create a tensor. Pattern is a tensor as well as sentence is a tensor here. These two are the variable names we have taken. Now, if we apply the regular expression for finding the full text match of the given words. So, we are applying these two as input parameters, and we are calling a function called tf dot strings dot regular expression underscore full match. Then if both are equal, we get a value of true in the sensors. So, in this way tensors can be taken to find out or to apply some of the string operations. Now, how this can be applied to a simple data set? What is the role of tf function when it is being applied to a simple data set? So, I have taken two data sets, one with feature name, other one is the label name. So, as usual we are importing the TensorFlow library as tf, and here the data sets have been taken for features 1.0, 2.0, 3.0. Labels have been taken with values 0.0, 1.0 and 1.0. Now, here we have to understand how we are making the features and labels. We are making these slices with respect to the data sets. So, tf dot data dot data set dot from underscore tensor slices, if I apply the two input parameters and I want to separately feature it the features and the label. So, in this way I can give a print statement where I am displaying all the features x dot numpy and all the labels with y dot numpy. So, this basic program can be utilized as an example code for how to use a tf function for just having a basic data set or calling the basic functions. Now, moving on to the another one more example of how this tf function can be used on a simple data set. See here, in this example a particular regular expression is being taken. So, this is the equation that has been taken, x square plus 2x plus 1. So, this particular function we just want the computation with a constant value of 3. So, if we supply 3, what will be the output, or if we supply the input values of 1, 2 and 3, what will be the output. So, here this particular function depicts an example of how TF function can be applied on a simple data. So, if you go through the entire code, as usual we are importing the TensorFlow as TF, and we are calling or we are defining a function called compute underscore polynomial, and this takes an input parameter x and it returns the value saying x power x square plus 2x plus 1. And here when you supply that constant value of 3 over here into the scalar input, you are calling that function compute underscore polynomial, which the control will be going over there, and here the input parameter value 3 is being supplied. Now, the function calculate 3 square plus 2 into 3 plus 1. So, if you see the value, it is 9 plus 6 plus 1, which is equivalent to the 16, the output. Now, moving on to taking the second example, how we can supply an array of values and get the output. So, here the one dimensional array is supplied with the input values 1.0, 2.0 and 3.0. Now, if this is being supplied and again the compute polynomial is being called, here we have 3 different values, one with input value 1, again the function will execute like this 2 into 1 plus 1. For the second input value it is 2 square plus 2 into 2 plus 1. For the third value it is 3 square plus 2 into 3 plus 1. So, if we see the output of each one of these, 1 plus 2 plus 1 is 4, 4 plus 4 plus 1 is 9 and 3 square is 9 plus 6 plus 1 is 16. So, in this way we can also perform or utilize the TF function for performing or how to apply functionality, calling a function in TensorFlow libraries. Now, this is one more example whereby we are having product of two sensors, 5 and 6 values. We defined a function called my function and it accepts 2 input parameters and returns the value of that. So, here I have called in my main program my underscore function with the 2 values 5 and 6. They got product and the value resultant is 30 that is being displayed. Now, apart from all the functionalities and usage of TF function, there is two more features that are there available in TensorFlow libraries, naming the conditional flow. So, how this depending upon the condition, how I can make a tensor to display. See here we are defining a conditional function here which accepts one input variable x. If x is greater than 0, we have to return x. If x is somewhat less than 0, we have to return the minus part of the x. Now, suppose in my main function I am calling the function with a negative value, minus 5 is being supplied. So, this condition gets executed and minus of minus 5 is a positive value. So, I got a resultant with a positive tensor value of 5. So, this example gives a clear understanding of how a tensors can be taken under the conditions also. You can even check a particular tensor with a condition flow. Now, moving on to the next concept, how to define a graph in case of a tensor and how to run a session. So, this example creates a graph with the inbuilt graphical function tf.graph. So, here with while we are creating the graph, we are taking it as two constant values 5 and 6 and those product have been considered for C. Now, how to create the graph session? See here with tf.compact.v1.session, when graph is equivalent to graph, as the session takes over, you need to run it and we have to print the result of the tensor. So, as 5 into 6 is 30, after executing all this we get an output of 30. So, this helps us to show that how we can depict a tensor's values that are there as part of a graph. Then, now moving on to actual project, how any TensorFlow project can be dealt. So, these are the steps that are available. First, we have to collect the data, we need to create a model and we need to add layers to the model, and we have to compile the model, do some training analysis, and we have to use the model. So, these steps, now I will show you an example of 2-3 project examples. We will not move deep into the project because we are now learning only the libraries part of it, when the actual concept of like applying CNN or RNN for a particular data set, at that point of time I will give you a brief explanation of all the full algorithm explanation. Now, for time being we can just see whatever we learned now in creating a tensor, where and all it is being applied. So, this example is a simple project which says that how the tensor flows helps in doing or predicting a particular model. So, till now we have learnt a library called tf.sensor, we know that how to create a sensor. So, this particular line gives that example, and after that we already know there are two different functions called multiplication and addition which can be done in case of a sensors. So, using these two, and we have some more buzzwords over here which we will be learning these functionalities in our subsequent sessions, whereby what do you mean by a sequential creation, how to create a model sequentially, and how to add the layers to that. Okay. Now, what are the other things we have learnt is, we know how to create a function, and under this function we are just creating a constant arrays, and here we are predicting the model, whereby we are calling the tf.sensor. Whatever the input values we have created the sensor, that has been given as a parameter over here, and some processing has been done here which depicts what to plot with respect to this particular project. Okay. Now, moving on to the second example of the project. Here this project also gives an example of how keras have been implemented using the tensor flows, and here we know about we know the statement of importing a tensor flow with a parameter tf, and we know this example gives the version of the tensor flow. Now, here this particular example introduces some other new functions with respect to keras implementation in TF. So, the buzz examples or functions that we came to know is the flatten, dense, dropout, and the model, keras sequential model. So, these are the something functions that we have to explore. So, this session gives you an idea of how these keras can be applied or used with the TensorFlow libraries. So, this is one particular example which we will be deeply discussing this in the forthcoming sessions when that particular model we are discussing. And here I have one more example how this image classification is done with TF and keras. This examples also we know that tensors and keras can be imported through the libraries like this, and this is a statement to load the MNIST data set that is already been available, how to do a pre-processing, how to build a model, how to compile, train a model, and how to fit the model. This is an exact coding of how this particular TensorFlow library is used to do all this. Okay. So, this particular example when we come across the actual CNN model, I will give you a brief explanation of this coding. For time being, we understood that, as I said, any TF project contains certain steps called collecting the data. So, this is the particular statement to collect or load the data, and here we do some pre-processing with that, with the image reshaping. See here, you know, with tensors only we can reshape the images, and after reshaping you can even make it to the categorical labeling part. Then comes the actual model building, where we apply different types of models like CNN, RNN, how it can be applied, and what functions can make these sensors to reshape it. Okay. And lastly, we will discuss about the loss functions and how the model can be compiled and fit. Okay. Now, this is one more example how these keras can be built to form a neural network, and here are the libraries as usual, and this is a simple sequential model, and this model is being compiled with some optimizers, and this model.summary gives the overall summary of the neural network that has been compiled and built. Okay. So, for time being, again once again saying the same thing, we will not go deep into this, how a ReLU function has been used over here, or how an activation function sigmoid is being applied, why it is being applied, what is the difference when it is applied before and after, how we can correct this. These all will be dealt when we deeply discuss about one particular deep learning model. Okay. And here some of the optimizer functions are also being discussed, loss functions are also be discussed. We should know the basic definition of these functions. Now, this is the overall picture about how the TensorFlow libraries have been helping us to do various real world applications. To summarize, in today's session, we have gone through what is a TensorFlow, what are the different libraries that are available, and what are the basic operations that we can do in TensorFlow libraries, like how do you can perform an addition, how we can perform a multiplication, how we can do subtraction over the TensorFlows, and we discussed about how these tensors are deeply involved in building the deep learning models or the machine learning models. So, in forthcoming sessions, I would like to introduce you to the next level of how to build a particular model, and before moving to that, we should know about the loss functions, how these can be implemented in the TensorFlow coding. Okay. So, thank you students.